Hey there, and thanks for tuning in. Welcome to a new episode of the Technology Addicts podcast by Avnet Abacus. In robotics and automation, it's all too tempting to focus on the big things: the precision of a robotic arm, the intelligence of the control software, or the speed of a production line. But behind every smooth movement and a seamless interaction lies an ecosystem of parts, some so small they're almost easily overlooked, that carry the burden of reliability. Connectors are a perfect example. While they may not be the flashiest part of a robot or a production line, when they fail, everything else grinds to a halt. In today's episode, we'll explore why connectors are mission critical to the long-term robustness of robotics systems, how details in their design make them reliable in tough environments, and how choices made in the design phase impact performance and uptime. To discuss this, we're joined by two expert guests who will help us unpack what makes connectors reliable and why these tiny parts can make or break an entire robotics system. Fabien Coutan is Section Manager Engineering at Hirosea Electric Europe, a leading Japanese manufacturer of electronic connectors, where over the past years he's contributed to and led countless customer projects and collaborated closely with cross-functional teams across Japan and Europe. And Marco Enge is Senior Product Manager at Avnet Abacus, and he brings extensive expertise guiding manufacturers through the thicket of design decisions involved in bringing new robotics applications to market. So Fabien, Marco, welcome to the studio.
Thank you.
Thank you.
So Marco, let's start with you. In your role at Avnet Abacus, you've worked with manufacturers at every stage of robotics development. And when a company is just starting out on a new automation project, what's the first big picture piece of advice that you'd give them to set them up for long-term success?
Well, we all know this, but it bears repeating. Every component matters, from the largest, most costly ones to the smallest, tiniest. All it takes to bring an entire production line to a halt is for a single component, a single interface to fail. So this is really our bread and butter at Avnet Abacus. By contacting us early in the process to select the right components, you not only avoid overlooking small details, you also cut the time it takes to design your solution, saving time and speeding up your ROI.
And Fabien, as a former FAE and in your current role of leading a team of 6 FAEs, you've seen these systems under real factory conditions. So could you share a story from your experience that shows how critical connectors can be, especially when something goes wrong?
Let me share a quick story from a few years ago that is kept in my mind. We were troubleshooting a robotic assembly line that had started acting in a strange way, like random shutdowns, misaligned movements, and sensors giving inconsistent readings. And this was in a high-speed automotive parts plant, including a lot of vibration with a high range of temperature and electrical noise from surrounding machines. The environment was tough, and we were facing delays and misalignment in the robotic arms movements. Everyone was convinced it had to be a software bug or a mechanical fault, but after hours of investigation, we found the real issue. It came from a very small connector. That connector, damaged by heat and vibration, was the culprit. It wasn't visibly damaged, but it was just loose enough to cause signal drops. Replacing it solved the issue instantly. It really shows how connectors are not just passive parts, they are part of the transmission line.
Yeah, and so you mentioned, Fabien, heat and vibration as causes of failure. Could you maybe walk us through the full range of stresses that connectors face in a modern robotics environment?
So what we can see in the main environmental stresses on connectors in robotics, they include vibration, that is, continuous movement can damage contact or housing. Heat, also, a high operating temperature can degrade materials, leading to conductivity issue. We have also dust. Contaminants, generally speaking, can interfere with connection, especially in outdoor or industrial environment. We have also repeated mating cycle, like frequent mating and mating wears out contacts and locking mechanisms. This factor require connector to be designed robust, sealed, and rated for high durability.
Okay, and Marco, despite their importance, connectors often don't always They don't get the attention they deserve in the design process. Why do you think engineers sometimes overlook them, and what risks does that create further down the line?
Connectors are often seen as simple hardware components connecting more complex systems. Because they're small, passive, they don't get the same attention as sensors, actuators, or even software. But this mindset can be very risky. An improperly selected connector can lead to signal loss, to interferences, to mechanical failure due to vibration or wear, and an unexpected downtime due to environmental degradation. Designers often focus on performance specifications and overlook how connectors really behave in real world conditions.
So, building on that, to both of you, what are the most common mistakes that you see engineers make when they select connectors, and what should they do differently?
Yes, so for instance, they are underestimating the environment. They are choosing connectors without considering vibration or IP rating, the ingress protection, or temperature range. In that sense, in our Hirose Electric Europe portfolio, we have the PQ50 series. That is a good example of connector, including all of this environment consideration in the development.
Ignoring mating cycles, using connectors not rated for frequent disconnection, leading to early wear. An example which counters this is maybe the IX series.
Another example of environment is to overlook the signal integrity, like not considering the shielding or the impedance matching in high-speed data line. For that, in our portfolio, we have the LF series that is a good match for all these criteria.
And then a very common topic is choosing based on cost alone, opting for cheapest connectors that don't meet a long-term reliability requirement.
And I would say one of the last points would be maybe the mismatch between connector and cable. So choosing connectors incompatible with the cable type or gauge from the customer, this can cause strain or poor contact.
So, you've mentioned a bunch of different product lines. What would you say are the hallmarks of truly reliable connectors under constant movement, high current, or harsh factory conditions? Fabien, pass this question to you.
In robotics, reliability means consistent performance under stress. So I would say like a reliable connector must maintain secure electrical contact despite vibration or movement. The connector should also withstand high current loads without overheating or degrading over lifetime. And this connector should also withstand environmental factors like dust, humidity, and also temperature changes. So these key features include a robust mechanical design, high quality contact material, and proven endurance under dynamic conditions.
So, Fabien, staying with you, could you break down how specific design features directly influence uptime and maintenance?
The direct impact of design feature on availability and maintenance cycle is the locking mechanisms that prevent accidental disconnection during movement or vibration. They also reduce downtime caused by loose or misaligned connectors. The contact materials like gold plating or high conductivity alloy resist corrosion and wear and ensures stable signal transmission over time, minimizing maintenance. The sealing IP rate protect against dust, oil, and moisture, especially in industrial or outdoor environment, and extend connector life and reduce failure rates. So each of these features contribute to longer maintenance intervals, fewer unexpected failures, and higher system availability.
So, robots are getting smaller, denser, and more complex. Fabien, how do you balance the push for miniaturization with the need for durability and robustness?
This balancing between miniaturization and durability in tight spaces is done with the use of high-density connectors with robust housing, the selection of materials that will combine strengths and flexibilities like LCP material or PBT material. We have also to design strain relief to protect cables and contacts even when there is a tight bend. And one of the last points would be maybe modular connector systems that allow compact layouts without sacrificing performance. So a smart design choice and collaboration between mechanical and electrical teams are the key to achieve both space efficiency and long-term reliability.
All right, thank you. Marco, looking ahead, how do you see advances in connector technology contributing to broader shifts in robotics like electrification, sustainability, or fully autonomous production lines?
I believe we will see changes in the development of connectors themselves and as well the applications they will be used in. Like you mentioned, in robotic areas or autonomous production lines. And this will also highly be influenced by artificial intelligence. On the one hand, the developing of the connectors themselves, suiting much better the requirements of the new applications, as well as artificial intelligence influencing robotics. We will see lots of new applications which we have not seen before and maybe even only thought of. So I think we are just right at this stage of a new era of changes in the technology of the components as well as of the applications they will be used in.
Yeah, it's interesting to see the connector as being kind of in the heart of this transition
Absolutely.
as well, as one of the enabling components. Fabien, is there anything that you'd like to add to this forward-looking impression?
Yes, I would like to highlight that Hirose connectors are innovating, cutting edge, and they answer many customers' requirements. So they are reliable. And I believe from what we have seen previously that it could solve many of these issues and it could help to have a good design of this robotics.
Okay, that already brings us to the end. To close, we always ask a signature question. To both of you, what is your current technology addiction?
Me personally, I'm addicted to wearables. I like to check my smartwatch many times per day, whether it's my steps, my heart rate, or even my sleep pattern. So it started as a way to stay healthy, but now I realize that sometimes I'm chasing those digital goals. So it's amazing how something designed to improve our well-being can also create this pressure to perform. So
All right, always running after KPIs. And how about you, Marco?
Well, actually, my addiction is really kind of how technology will develop. So I'm really into reading and following people who are at the leading edge of technologies. So looking beyond, let's say, like a 5-year time frame. So what's coming next? How things will develop. So this is really kind of my addiction. I'm highly interested in roadmaps of things to come.
Man, you have a great perspective from where you are at Avnet. I think you can see into the future. That's exciting. Okay. And with that, I'd like to thank Fabien and Marco for joining us for this episode of our podcast. If you're interested in learning more or reaching out to our guests, you'll find all the contact details and resources in the show notes. So to all of our listeners, thank you for joining us today. And we'll catch you next time for the next episode of the Technology Addicts podcast.
thank you.
Thank you very much.